And this question says work out 2 plus root 3 times 2 minus root 3. Give your answer in its simplest form. Okay, now this takes us to a topic I call surds. Okay, now what is a surd? First of all, a surd is a square root that cannot be reduced to a whole number. Okay, the square root of a number that's not a whole number. That cannot be reduced to a whole number. Okay, the square root of a number that cannot be reduced to a whole number. For example, square root of 4 is not a surd, because square root of 4 can be reduced to a whole number, and that's 2. But square root of 5 is a surd. Okay, why? It cannot be reduced to a whole number. Okay, now there are two basic rules of surd I'll need us to talk about. The first one is that when you have square root of a times b, is same thing as square root of a times square root of b. Okay, for example, square root of 5 times 5 is same thing as square root of 5 times square root of 5. Square root of 5 times 5 is square root of 25, is equal to square root of 5 times square root of 5 is 5. Okay, so you see that square root of a times b is the same as square root of a times square root of b. Now the next one is that square root of a times square root of a is equal to a. It's actually a rule, and you can even use it here. Now from here, that square root of 5 times square root of 5 is 5. Okay, these are the two basic rules. Now let's try and multiply out what we were told. Now we're told that 2 plus root of 3 times 2 minus root of 3. Now the same way we try to expand. Okay, we're going to do this one now. You're going to multiply this by everything here, multiply plus root 3 by everything here. So it's more like saying 2 times 2 minus root 3 plus root 3 times 2 minus root 3. Okay, now multiplying out, you're going to have 2 times 2 is 4, 2 times minus root 3 is minus 2 root 3, plus root 3 times 2 is plus 2 root 3, plus root 3 times minus root 3. Plus times minus is minus. Okay, then root 3 times root 3, according to that our first rule, is 3. Okay, you have that plus root 3 plus 2 root 3 minus 2 root 3 plus 2 root 3 is 0. So you have 4 minus 3, and that will be 1. Okay, now that's another thing too we're going to take into notice. Okay, that if you have a number, now if you look at this surd question very well, you find out that 2 plus root 3 times 2 minus root 3, okay, is just 2 times 2, 4, minus root 3 times root 3, that's 3. Okay, equal to 1. Okay, now this is more like difference of two squares a bit, not really difference of two squares per se, but is more like a rule of surd in a bit. Okay, that you can just use to easily go straight to the answer. And this now we normally use it in rationalizing surds. Okay, if you have this now as the denominator, okay, you always multiply with this, or if you have this as denominator, you always multiply with this to clear the fraction. Okay, is worth noting actually that a number plus the root of another number multiplying by an additive, this is plus and this is minus, so this is an additive inverse of this. So any number, if you have 5 plus root 2, the additive inverse is 5 minus root 2. Okay, if you have 4 minus root 5, the additive inverse is 4 plus root 5. So any additive inverse of a number, when you multiply the surd, okay, additive inverse of a surd number, okay, when you multiply them out, you're going to have a whole number. Okay, that's the ideology we're going to use when we talk about rationalizing surd. So now let's look at rationalizing surds. Okay, now when you're talking about rationalizing surds, all you just mean is clearing the denominator of a surd, okay, and making it a whole number. You're just getting rid of the surds at the denominator of a number or of a fraction. Okay, for example, 5 over root 6. If you're asked to rationalize it, it just means multiplying. Now whenever you're rationalizing, use the mentality of root of a number times root of the same number is equal to the number. Okay, that's the mentality you use. So for you to get a whole number here, you have to multiply by root of the same number, so you get that number. So it's more like saying times root of 6 over root of 6. I'm doing root of 6 over root of 6 because if you cancel out, you have 1. So if you multiply this by 1, you didn't change it, it's still the same thing. Okay, so this time this is going to give you 5 root 6 over root of 6 times root of 6 is 6. So this will now be the answer of the rationalized surd. Now if you're also given maybe 5 over 2 plus root 3 and you're asked to rationalize it, you can say that this has a root on the denominator, so it's not rationalized, so you need to rationalize it. Now from what we said earlier, you have to multiply by the additive inverse of this, okay, so that you'll be able to clear this fraction. And the additive inverse is 2 minus root 3 over 2 minus root 3. You don't just multiply by on the denominator only. You whatever you multiply with on the denominator, you also multiply with the same thing on the numerator. Why? So that you won't change anything, so the fraction will still be the same. So this is the same thing as 5 into 2 minus root 3 over 2 times 2 is 4 minus root of 3 times root of 3 is 3. Okay, now it's going to give you 5 times 2 is 10 minus 5 root 3 over 1, which is 10 minus 5 root 3. Actually, basically what you're going to be looking for is, if you're asked to rationalize and you have a denominator, ask yourself what you multiply with that denominator to make this a whole number. If it's root of a number, just multiply with that same root of a number on the denominator and numerator. Okay, then you'll be able to get it. Then for a number like this, just look for the additive inverse, okay, and multiply the numerator and the denominator with it, and you'll be able to clear the surd. So that's how you work on